So let's talk about block usage, right? So far we saw how you could use other methods that use blocks like each, dot each, and so on. But how do you write your own methods and have them use blocks? So there are two ways. You could have the explicit way and the implicit way. And this is just a summary of how to do that. You use for the explicit one, you use the ampersand in front of the last parameter, and then you use the call method to actually call the block. It's explicit. With the implicit version, you have a block given method that Ruby lets you test if a block was passed in to a method or not, and then you yield to call the block. You don't actually call it explicitly, you just yield control to that block. So for the explicit, well, let's see an example of that. You have 2 times explicit method that takes in some block as parameter, right? So this is not really a method parameter, but it's a block, and it's always passed in as the last parameter to a method. So that's what this ampersand means. It's telling the method this is not really a parameter, this is a block. And then you could test for it. You could say return no block if some block, this parameter here, is nil. But otherwise, stay inside the method, don't return, and then call this block 2 times, right? You're doing some block.call and some block.call, and that's what you're trying to do. You're trying to execute, in this particular case, the block 2 times. Now, you could also have parameters, but again, those parameters would have to go before you pass the block in. So in this case, some var is your variable, and you could actually use that variable or any variables you define inside the method to pass into a block, and they become block parameters defined between those pipes in the block definition. So some block.call, you pass the variable, and you pass the variable again. So 2 times explicit returns no block because you didn't pass the block in, it will return no block. But if you pass in the block after the method, and that's your only parameter in this case, so it knows that some block is that block that you are trying to execute, and then it calls that block 2 times, once and twice. In this case, you're also doing it 2 times, but you're also passing a parameter. So in this case, you're saying pass the parameter hello, and that parameter ends up being passed in as a parameter to the block, which is what this is doing, and then it just prints it out. So that's the explicit method. The implicit method is very similar, but very different. And in this case, the method definition, the method signature, doesn't indicate anything about a block being passed in, but you could pass it in, even though the signature method doesn't let you know that. It's implicit, right? So you could do return no block unless block given. So block given is a Ruby method that tests if a block was given or not, and then you could do things based on that. If you absolutely need the block, then you return. There's nothing to do here. Otherwise, you could continue and you could have separate behavior for if a block was passed in or not. And in this case, you're not explicitly calling the block like in the previous slide. You're just yielding control to the block. So you need to do it 2 times. So this is a similar example to a previous slide, but a little bit different. You want to return no block unless a block is given. And then inside the method, you have an array, 1 and 2, and you want to add those values. But before you add the values, you actually want to pass the values to a block, right? So you yield the control of whatever is array 0 to a block, and then you yield the control of array 1 to a block. And again, the block definition is something that you're going to pass in when you actually call the method. And then after you have those 2 values defined, you actually add return value 1 and return value 2. So in this case, 2 times implicit behavior is very similar. You pass the block in, it yields to it 2 times. And then in this case, you basically pre-processing the values before you use them. So you say that the value in the block increase it by 10 times. So instead of these variables being 1 and 2, they actually end up being 10 and 20, which returns 30 at the end of the day. And this implicit behavior is a behavior, if you remember from a few lectures ago when I showed the enumerable module and how you could only need to define one method, each method. So that's where I used the yield behavior, and I said that I would explain it later. So I'm explaining it now. That yield behavior is basically defining a block, passing the control to a block. So what else can blocks be used for? Blocks are very useful as object initializers. So a lot of times you have an object that has a lot of attributes, and you always want to have objects in completely initiated state when they are created. Now, it would be nice to initialize them all before the object is used by passing them into a constructor, but sometimes you have 5 or 10 or 15 attributes that you need to initialize, and it's not practical to pass them all in the constructor. It just ends up being very long and messy. So what you could do is you could use a block to initialize the object instead. How would you do this? So let's say you have a person class, and in this case has 3 variables, but it could have 5 or 10 variables. So what you could do is in your constructor you could say yield itself, which is the instance that you're trying to create. If a block is given, yield itself to a block. So this is what it ends up looking at like. It's person.new, and then you have a block that you're yielding to with this yield self. So then inside the block you could do initialize the name, initialize the age, initialize the height, and so on, which lets you initialize the instance of a person. So 2 different values, and then you could print out the initialized instance of a person as you do in this case.